Hello everyone, so for today's lecture I'm going to be going over chapter 1. I'll be covering lessons 1.1, 1.2, 1.4, and 1.5. And basically what this chapter is about is the basic math, right, that we learned before in maybe elementary school, middle school. Sometimes we have had even reviewed it in high school, right? So that's basically the material that we're going to go over for today. It's just refreshing, that math that you have done way before, and that probably sometimes you're like, okay, so how did we used to do this? Well, that's what we're going to do today. It's just a review of something that you have already learned in the past. So let's go ahead and get started with fractions, right? So fractions, what are they? A lot of people, a lot of students and people get afraid of this, or as soon as they see a problem that has a fraction, they just freak out a little bit because they're overwhelming to look at. Fractions consist of two numbers, right? And they're just it just seems like a lot going on whenever you write them down. However, let's think of fractions just as numbers, right? Just as parts of a whole, right? So that's basically fractions. So I'm going to go ahead and write the definition that has been provided by the textbook. So a fraction is a number in the form a over b, where b, oops, so where b cannot equal 0. So we're not allowed to have a 0 on the bottom of a fraction. And the reason why we're not allowed is just because it doesn't make sense. Logically, realistically, it doesn't make sense to have a 0 on the bottom. What do I mean by that? Let's try to think that we have 7 cookies, right? And then I come with the 7 cookies. And then I tell you to divide the 7 cookies between 0 number of kids. So there are no kids, but I'm still asking you to divide the 7 cookies between those 0 number of kids. So probably your answer will be like, what? Like, that makes no sense. If there are no kids, why are we even dividing, right? So that's the reason why we're never allowed to have a 0 on the bottom. It just doesn't make sense. Realistically, logically, it's not reasonable to have a 0 on the bottom of a fraction. So the fractions consist of two parts, right? Two numbers. So we have a and we have b. So a is what we call the numerator, and b is what we call the denominator. You're probably going to hear me saying a lot of numerator, denominator. So numerator is the number on the top, denominator is the number on the bottom. Okay? So now let's go ahead and talk about doing actual operations with fractions, right? So let's talk about multiplication. So whenever we want to multiply, let's say we want to multiply the fraction a over b times c over d. Let's remember a, b, c, d represent numbers. We just haven't clarified what numbers are they, but they represent numbers. When we want to multiply, what the rule says is that we multiply numerators and we multiply the denominators. So that's basically with each other. So we will have a over b times c over d equals a times c over b times d. So we're kind of like multiplying across. Number on the top times number on the top, numerators, and then number on the bottom times number on the bottom, denominators. we multiply the numerators and we multiply the denominators, and we end up getting our multiplication. Let's go ahead and do a couple of examples. So the first one I'm going to do is 8 over 25 times, I keep doing that. So for multiplication, we can use like a dot to represent times, right? Or we can use the little X mark. I'm going to use a dot for now, and then over 15 times 15 over 32. Not over 15, times 15 over 32. So something that I'm noticing here is that we have numbers that can be reduced. By reducing, I mean that a number on the top and a number on the bottom are both divisible by the same value. In this case, I see that I have the number 8 and I have the number 32. They're both divisible by number 8, right? Then I can also see that I have a 15 and I have a 25. They're both divisible by the number 5. And notice how I'm pairing them, one on the top and one on the bottom. That's the only way that we can reduce. So we said that 8 and 32 are divisible by 8, so I'm going to divide both by 8, and then 25 and 15 by 5. I keep the multiplication, and then 15 divided by 5, and 32 divided by 8. Okay. And this will give me 8 divided by 8, which is 1, over 25 divided by 5, which is 5, times 15 divided by 5 is 3, over 32 divided by 8, which is 4. Now that they have been reduced, notice they're simpler numbers. I don't have to do like big multiplications like 25 times 32. Now I can just multiply across, numerator times numerator, and denominator times denominator. So 1 times 3 is 3, and 5 times 4 is 20. And there it is. Now 3 is a prime number. That means it cannot be broken apart anymore, cannot be reduced. 20 is even, but 3 is a prime, so that's the answer. That's the final answer. That's the first example. Let's go ahead and try another one. Now this one's going to be a little bit longer because it's going to require us to do an extra step. So we have for this one 3 3/4 times 2 wholes and 2/3. Now, there's a special rule for this type of mixed numbers. So we call them mixed numbers because we have a whole number and we also have a fraction, right? Now, whenever we are working with operations of fractions, it's always easier to convert them into proper fractions. That means that the number on the top will be greater than the number on the bottom, right? So the way that we can convert a mixed number to a proper fraction is that we multiply the whole number by the denominator, and then we add whatever the numerator is. So here for this one, I will be doing 3 times 4 and then plus 3. I will do 3 times 4 and then plus 3 over 4. So I keep the same denominator. Now same thing is going to happen with the other one. We bring down are going to decide for multiplication because we're multiplying both. Now 2 times 3 and then plus 2. So 2 times 3 and plus 2 over 3. Notice how I'm keeping the same denominator, right? Now 3 times 4 is 12, plus 3 is going to give me 15, so 15 over 4, times 2 times 3 is 6, plus 2 is going to give me 8 over 4. Okay? And then let's go ahead and see if there's any pairs, right, that we can actually reduce, right? If there are any numbers from the top and bottom that we can reduce without to make this whole fractions simpler and not a quick. Then I'm going to go ahead and click line here. Drives me crazy because I don't want you to like get mixed with the value from the first example. So here I'm noticing, for instance, that 15 and 3 are both divisible by 3. So I'm going to divide by 3 and I'm going to divide by 3. I'm also noticing that 4 and 8 are both divisible by 4. Just here. Okay. So if I go ahead and divide those values, right, by 3 and 4, I will end up having, I'll end up having 5 over 1 times 3 divided by 4, it's 2 over 1. Which at the end is going to give me 10 over 1. Remember, we multiply across. Okay? I know it looks a little bit messy, but again, the idea is to reduce as much as we can and then multiply, right, the values that we have here. So let's go ahead and keep on going. Now we have division. So for division, the rule is going to be a little bit different. The way that we write it is, let's say we have A over B and divided by C over D. So this is how a division between two fractions is going to look like. And what the rule says is that is we let A, B, C, and D represent numbers so that B and D do not equal, B, C, and D do not equal 0, then when we divide A over B by C over D, this is equal to A over B times D over C. So what's happening is that CD is switching to its reciprocal. The reciprocal of a fraction is whenever you switch it, same values, so just switch. And what this is causing is that when you do the reciprocal, then this becomes a multiplication. We're not working with division anymore, it becomes a multiplication, which is basically the easiest mathematical operation that we can do with with fractions. Okay, so let's go ahead and work on a couple of examples. Let's say I have 2 over 7, and it's being divided by 3 over 5. And the first thing that I know is that this second fraction has to swap it. We have to convert it into a reciprocal. So 2 over 7 is going to stay the same. 3 over 5 will actually become 5 over 3. And then this division will become a multiplication. And now we can just multiply across. 2 times 5 is 10. Over 7 times 3 is 21. And that'll be our solution. Let's try another example. Let's say I have 9 whole and 1 over 6 divided by 5. Now let's remember, whenever we have a mixed number, we want to convert this, right? So I'm going to do 9 times 6, and then I'm going to add 1. Okay? So 9 times 6 is 54, so I'm going to have 54 plus 1 over 6, and then divided by 5, and to this 5, I'm going to put a 1 in the bottom. This becomes 55 over 6 times 1 over 5. So maybe this 5 over 1 flipped, and that division became a multiplication. Now from here again, we want to find if there are any pair of numbers that we can simplify or we can reduce. Here I'm seeing that 5 and 55 are both divisible by 5. So then this right here will become 55 over 5, which is 11. So this will become 11 over 6 times 1 over 1, which is 11 over 6. 11 times 1 is 11, 6 times 1 is 6. And we have concluded with that problem. Okay? So let's keep going. Now we're going to talk about addition and subtraction of fractions. And for me, this has been one of like the, I think addition and subtraction can be like the more complicated part of fractions, like the more complicated operations that we can do with them, simply because we have a specific rule that we need to follow. So let me, I'm going to go ahead and go over the rules for addition and subtraction, and then I'm going to show you an example. So for the rules of addition and subtraction, we have, I'm going to let A, B, and C be numbers such that C cannot be 0. So we have A plus B over C. Actually, let me go back. I'm just jumping one step ahead. Yeah. Okay. Okay, so I'm going to put that later. So I'm going to have A over C plus B over C is equals A plus B over C. Notice how I'm keeping that C. I'm not adding C and C. I'm just keeping one single letter C, right? And if I have A over C minus B over C, this is equal to A minus B over C. Now, something that I do want you to notice is how for both we have the same denominator. And that's the important part of this, of addition and subtraction of fractions. We need to have the same denominator. If we do not have the same denominator, we cannot add or subtract the fractions. So I'm going to go ahead and make a note on that. So they call this common denominator. Right, in order to add or subtract fractions. If we don't have the common denominator, if we don't have the same denominator on the bottom, then we need to find the LCD. So if we don't have same denominator, then we must find the LCD. And that stands for least common denominator. Remember that we usually want to have fractions as reduced as possible, so that's why we're looking for the least common denominator. Sometimes we're going to find denominators that can be huge, right, and they're for them to be common, but then it takes a hassle for us to reduce. So we always want to first find the least one, okay? So I'm going to go ahead and review an example, or go over an example, not review, go over an example on how to subtract and add fractions, right? So the first one would be 11 over 12 minus 5 over 8. Now, let's remember that if we have the same denominator, we don't have to worry about finding LCD. We just have to worry about finding the LCD if we don't have the same denominator. That's when we find the LCD. If we have the same denominator, we don't worry about it. Now, because finding the LCD is a little bit more complicated, I'm going to be going over examples where we don't have the same denominator. Okay? So here we have 11 over 12 minus 5 over 8. I can see I have 12 and I have 8, right? So we don't have the same denominator. We're gonna have to find the LCD. So how do I find the LCD? Well, the first thing that I'm gonna do is I'm gonna go ahead and place down the times tables of 8 and 12. So the times table of both denominators. So for 8 we have 8, 60, 24, 32, 40, and you can keep going. For 12, we have 12, 24, 36, 48, 60, and you can keep going. So from there, I can see that both the times table of 8 and the times table of 12 have the number 24. Now, I think they both have later 96. That's way higher. We want to find the least, right? So we have 24. So that means that my LCD equals 24. Right? So what do I want to do? I want for both denominators to become 24. So I'll do 11 over 12. Now I know that 12 times 2 is going to give me 24. If I have a fraction and I'm multiplying on the bottom, I need to multiply on the top as well. So whatever you do to the bottom, you also do to the top. Okay? And then I have minus 5 over 8. Now this 8 also needs to become 24, so I'm going to multiply times 3. So now 11 times 2 is 22, over 12 times 2, which is 24, minus 5 times 3, which is 50, over 8 times 3, which is 24. So again, what happened here, I multiply times 2 and I multiply times 3 to get this 24. Okay? That's our goal. We want to get the same denominator so we can apply this rule, right? Where we can add the numbers on the top or subtract the numbers on the top. So this 22 over 24 minus 15 over 24 will become 22 minus 15, which is 7 over 24. And 7. Okay? It cannot be reduced anymore. 7 is a prime number, so it's not divisible by any value. So it will be 7 over 24. Okay? So let's go ahead and go over another example. I'm like complicating myself right now. So I am still learning how to do like this whole online, like taking notes online. You see, I can try to erase it and try to work on it. Wait, okay, so I'm gonna have to do it by parts. Cool, awesome. Let's take what the whole thing. Let's do this one. Oh, I'm erasing. Okay, so I guess everything has to be inside of the top area. Okay, there, cool. So let's go over another example. This one is consists of 3 different fractions. We are going to have 1 over 3 plus 5 over 6 plus 3 over 4. Okay. Again, I can see that I don't have the same denominator, so I need to find the LCD. So that's my first step. Need to find the LCD so we can go ahead and add the fractions, right? So for the times table of 3, I'm going to go ahead and write down the times table of 4 and the times table of 6. So for 3 we have 3, 6, 9, 12, 15, and so on. 4 times the root of 4, we have 4, 8, 12, 16, 20. Oh, it's not even so then we have 6, 12, 18, 24, and 29. Okay, so again, we want to find that LCD. From here, I can tell that 13, 4, and 6 have a number test. Okay, so that means that my LCD equals 12. Okay, so remember what that means is that I want all numbers on the fractions, on the denominators of the fractions to become 12. So I have 1 over 3. Now I can 3 times. We don't add, we don't subtract, we multiply. 3 times what number gives me 12? Well, that is 4. So I'm going to go ahead and multiply times 4, the bottom and the top. Plus 5 over 6. 6 times what gives me 12? 2. Times 2 times 2. Plus 3 over 4. 4 times what gives me 12? Times 3. And I'm going to go ahead and multiply the top and the bottom. So I can say I'm multiplying times 4 times 2 and times 3. So I can get that LCD. Okay? Now when I multiply, this becomes 1 times 4 is 4 over 3 times 4, which is 12, plus 5 times 2 is 10, over 6 times 2 is 12, plus 3 times 3 is 9, over 4 times 3 is 10. Right? And now that I have the same denominator, I can go ahead and add the numbers on the top. So 4 plus 10 will be 14, plus 9 will be 23. So this is 23 over 12, and we are done. Yeah. So that is adding and subtracting numbers with different denominators. Notice that once we have the same denominators, we only have to add the numbers on the top. You don't add the denominators, you just keep the same one. Okay? So that's the first part of chapter 1. I think that's lesson 1.1. Let's go ahead and now talk about exponents and order of operations. So first thing I want to talk about is basically what is the order of operations, and then I'm going to go ahead and include the exponents. But let's go ahead and what is the rule for the order of operations. So for order of operations, we use what we call PEMDAS. And PEMDAS is basically the priority or the order in which we do each operation whenever we are giving an expression, right? P stands for parentheses. So we have parentheses with numbers being added or subtracted inside. That's the first thing that we want to simplify. E is for exponents. When we have exponents, we do the exponents after the parentheses. Then we have multiplication. Then division. A is for addition. And of course, S is for subtraction. Now, I just want to make sure that I'm clear. Multiplication and division go kind of by hand, and so do addition and subtraction. Usually for these two and these two, we work on them from left to right. So if we have, I'll do an example. So let's say I have 1 times 2 divided by 1, let's say. Then I go from left to right. So first I have to do the 1 times 2, and then I divide by 1. So 1 times 2 is 2, divided by 1 equals 2. Now, same thing for addition and subtraction. Let's say I have 2 minus 3 plus 4. Even though subtraction comes second, right, or comes after addition, it is, if we go from left to right, subtraction is coming up first. So first I do the 2 minus 3, which is negative 1. And I'm going to talk about that later. Negative 1 plus 4, which will be 3. Okay? So just making sure that we understand that multiplication and division and addition and subtraction have kind of like the same priority if they are next to each other. So we go always from left to right. Okay? Now, I also wanted to talk about exponents. So, I did not add that right here. We're going to be using it for order of operations right now, for the example that I have for you. So, exponents. What is the definition of an exponent? Well, basically, an exponent is a probably weird. An exponent represents repeated multiplication. Okay? So an example, it can be if we have 2 to the third power, this is 2 times 2 times 2. Okay? And again, let me put 2 to the 3. 3 is the exponent, and 2 here is called the base. So the exponent tells the base how many times it has to multiply itself. Okay? Now, if we have 2 to the third power, that doesn't mean that we're going to do 2 times 3 and then equals 6. No. It means that we're going to do 2 times 2 times 2. Okay? Let's go ahead and do an example here on this side. Let's say I have, or another example. If I have 3 to the fourth power, again, it's not 3 times 4. It means 3 times 3 times 3 times 3, which ends up giving us 81. Or we have 3 over 4 to the third power. It doesn't mean that we're going to do 3 times 3 or 4 times 3. No, it means that we're going to do 3 over 4 times 3 over 4 times 3 over 4. And then we multiply across, right? Because these are fractions. So we multiply numerators and denominators. So 3 times 3 times 3 is 27 over 4 times 4 times 4, which is 64. Okay? But those are multiplications. Again, they just tell us how many times do we multiply a value by itself. Okay? Now let's go ahead and use that information that we just learned and PEMDAS to see how do we apply this into order of operations. So let's say I have 12 times 3 and then minus 2 plus 1 to the second power divided by 9. Okay, so first thing that we need to do is the parentheses. And I'm seeing that I have some parentheses here. I have two values inside of that parenthesis that can be simplified. So that's the first thing I'm going to do. I have 12 times 3 minus. I combine, I simplify whatever is inside the parentheses. 2 plus 1 is 3. To the second power divided by 9. Now, second thing that we need to work with is exponents. So I do have an exponent here. 3 to the second power. Remember, this doesn't mean 3 times 2. It means 3 times 3, which is 9. So I'm going to have 12 times 3 minus 9 divided by 9. Let me bring that down a little bit. So, again, so 12 times 3 minus 9 divided by 9. And again, this 9 is coming from here. Cool. Next step is multiplication and division, right? So I can see that I have a 12 times 3 down here, and then I have 9 divided by 9. I can go ahead and do that. 12 multiplied by 3 is 36, minus 9 divided by 9 is 1. So 36 minus 1 is just 35. And that'll be my final solution. So when we are evaluating or simplifying using order of operations and there's so many numbers, at the end we need to have one single value, right? No addition, no subtraction, just one single value, okay? Cool. So now let's go ahead and talk about sets of numbers. So let's see what different type of numbers we have in math. These are the type of numbers that you're going to be working with. I'm going to go ahead and give you just a definition and an example. These are pretty much definitions that I'll be using during the course, so it's more of you understanding what do I mean when I say integers, or what do I mean when I say natural numbers or rational numbers, right? So it's just to know like the definition beforehand. So integers are basically natural numbers. You're probably thinking, well, I don't know what is a natural number yet. I'm going to go ahead and go over that right now. So it's natural numbers. They're negatives. And the number is 0. Okay. And so an example of a set, okay, usually sets are open with this curly bracket. We don't know where it starts, but we can say that it's going to start from -3, -2, -1, 0, 1, 2, 3. This is an example of a set of integers, or this is a piece of the set of integers. Again, basically, integers is natural numbers. They're negatives and zeros, so we have, notice how we have the positives, we have 0, and we have the negatives, okay? Now, natural numbers. What are natural numbers? Well, these are whole counting numbers. So it's like what kids learn to count when they're little, right? What did they start counting? They start with 1, 2, 3, 4, 5. So basically, it's the numbers that we use to count with. So the set will go 1, 2, 3, 4, 5. And I'm going to do dots just to show that it keeps going. It doesn't stop. It's an infinite set. The same thing with integers. Integers, notice how it just has zeros and then it has negatives. Natural numbers don't have negatives. Okay, so these are no negatives. Again, because when we count, we don't use negative, right? We only use positive, so no negatives in natural numbers. Rational numbers. So basically, rational numbers are numbers that are, they can either be repeated decimals or they can be whole numbers. They basically are numbers that are not super complicated. So that means that if they have a decimal, the numbers after the decimal are going to be the same, or they're just going to be one number after the decimal, two numbers, right? But it's not going to be a super complicated value. Those are rational numbers, but I'm going to give you the actual definition. So that's basically any number of the form p over q, so it's kind of like a fraction, where p and q are integers. That means that they are whole integers, and q is not equal to 0. So the beginning we can never have 0 in the bottom of the fraction. Example, so this can be, it can be 1, right? Because 1 can be written as 1 over 1. It can be negative 4 over 3. It can be 5.6. It can be 0.333. It can be negative 2 because we can write negative 2 as 2 over 1. So all of these are examples of rational numbers. And now irrational numbers are basically whatever is not rational. So these are numbers that cannot be written as a fraction. Here 5.6 can be written as 56 over 100. Not over 100, 56 over 10. 0.333 can be written as 1 over 3. So all of these numbers that we are seeing here in this list can be written as a fraction. Irrational numbers cannot. So these are a set of numbers that cannot be written as fractions. Or as a quotient of two integers. An example can be the number pi. So pi is like 3.14569, and then it keeps going, and none of the values are repeated. So it's just like random numbers coming after the decimal point. Another one can be the square root of 2. If I use a calculator and put in the square root of 2, I'm also going to get a super long decimal number that is probably never ending, and that it doesn't have any like repeated values. There's no pattern. So these are two examples of irrational numbers, okay? And those are the most popular ones. Okay, now let's go ahead and talk about addition and subtraction of real numbers. So when we're talking about real numbers, I'm actually going to be referring to integers. So integers, the number is negative, positive, whole numbers, and 0, okay? So we have specific rules because when we're talking about real numbers, that means that we are including the positives and, as I said, negatives. Remember I said we're talking about integers, right? So there's just some rules that we use now that we are talking about negatives, right? Let's go ahead and keep in mind, let's go ahead and just keep in mind that we're kind of working with a thermostat, right? So for temperature, and we are kind of like either adding more temperature, more degrees, or we are subtracting or going down, right? Decreasing in temperature, where we start seeing negative values, right? I mean, we also have money, right? Whenever you owe money to a credit card, debit card, or credit card, the numbers will be negative, right? They will start showing as negatives, or whenever you take out money from the card, it shows as a negative value. So let's just try to keep in mind like examples of real life where we actually use negative values, right? So for addition, if we're adding numbers with the same sign, the rule is that 1, we have to add the values, and 2, we keep their sign. Now, what do I mean by that? Let's say we have the number negative 1 plus negative 2. Notice how they both have that negative value, right? And we are adding. So, because we both have that negative value and we are adding, we're going to add 1 and 2, which is 3, but then we're going to keep the negative. So we add the values, but we keep the negative. It's like thinking we are at negative 1 degrees Fahrenheit, but then we added another negative 2 degrees. So instead of going up, it's going to go down another 2 and then negative 3 degrees Fahrenheit. Another example can be if I have 2 plus 5. Both values are positive, so all I have to do is add 2 and 5, 7, and it's going to be a positive 7 because they're both positive. Okay? Now what happens when we are adding numbers with opposite signs? Well, if we're adding numbers with opposite signs, we have to first find the difference. So find the difference of the numbers. In other words, subtract them. And then the second step is to keep the sign of greater value. So you're finding the difference, that means you're subtracting the smaller value from the biggest one, and then we keep the sign of the greater value. So if we have opposite signs, we subtract and we keep sign of greater value. If we have the same sign, we add and we keep the sign of both. Okay? Just trying to come up like the keyword. So opposite sign, subtract, keep sign of greater, same sign, add, and keep sign of both. Okay? So an example can be if I have, let's say, -1 plus 4. I'm noticing that here 1 is negative and 4 is positive. So I'm going to find the difference. What is the difference between 1 and 4? Well, that's 3, right? So it'll be 3. I subtract 1, 4, take away 1, it's 3. However, because 4 is greater and it's positive, then this is going to be a positive 3. Okay, so 4 is greater and positive. And that's what I mean when I say keep the sign of the greater value. Okay? Or let's say we have 5 minus 9. 5 will be a positive. We don't see the positive right here. I'm going to go ahead and put it. So we have a positive 5 and a negative 9. Opposite signs, different signs, so find the difference. Difference between 9 and 5 is 4. But because 9 is greater and it's negative, this is going to be a negative 4. Okay? So subtracted values, kept the sign of the greater. Okay? We put the negative. Now let's talk about subtraction. So for subtraction is pretty similar to the addition. It's just subtraction is the inverse. So we're gonna have to do the inverse of some of the values at one point. So subtracting values. Oops. So subtracting two values is the same as adding the opposite of the second value. Or basically whatever values after the negative, after the subtraction, right? So, for example, let's say I have 5 minus 3. This is basically the same as saying 5 plus negative 3. So 3, right? Let's say it's like positive. Now, I put a plus, but then 3 became negative. So 5 plus negative 3, right? 5 is positive, 3 is negative. Opposite signs, so we go back to the roots for addition. Opposite signs, subtract values to find the difference, which is 2, and keep the sign of the greater value, which is positive. Okay? Here 5 is positive, so it's positive 2. Another example can be, let's say if I have 5 minus negative 3. Oh, this one's different. This 3 is negative, right? And then we still have that negative outside from the subtraction. So what's going to happen when we keep the 5? Remember, the subtraction will become positive. And then we do the opposite of the second number. So like 3 will become positive. So this is 8. Okay. So if we have, again, notice how that negative became into that positive. So usually what people say is that when we have two negatives make a positive, because we know we are turning that subtraction into an addition, and we're switching the sign of the second value, right? Because we're adding the opposite of the second value. So that means that two negatives make a positive, okay? And so that's how we subtract integers, how we subtract real numbers, right? And how we add them as well. So keep in mind these rules. Again, I'm really trying. I know this is like not the super cleanest notes. However, I'm gonna be sending you a copy of this, and just have it updated there in Canvas. So if you want to go back and read the notes, right? But this is basically what the what adding and subtracting um, real numbers is. So now let's go ahead and talk about multiplication and division of real numbers. Okay. Okay. So we're almost towards the end. This is the last part that I'm going to talk about. Multiplication and division of real numbers. So there's like a really specific way of multiplying and dividing real numbers, or positives and negatives. And that pretty much will be if I have for multiplication, so let me multiplication here, so this is multiplication. It's the same rule, because one is multiplication, the other one's division. So basically what it says is that if I have a positive times a positive, the answer will be positive. A negative times a negative, and the answer will be positive. A positive times a negative, answer will be negative. Negative times positive, the answer will be negative. So if I have a positive value times a positive, it's going to be positive. Negative value times negative, it's positive. Positive times negative, it's negative. And negative times positive, it's negative. Now, what I'm going to do, I'm going to go ahead and highlight the positive. So positive and positive, it's positive. Let me see, do we have, no, we don't have red. Okay, so negative times negative makes a positive. Positive times negative makes a negative. You probably already noticed the pattern, right? Negative times positive makes a negative. So basically, what the rule is, there is that opposite signs result in negative. And a negative. And same signs, doesn't matter if they're both negative or positive, same signs result in a positive answer. Okay? Same rule applies for division. So if I have a positive being divided by a positive, the answer will be positive. Negative divided by a negative equals positive. If I have a positive divided by a negative, the answer will be negative. And if I have a negative divided by a positive, answer will be negative. Now, where I have seen people getting confused with the division, it's if we are working with fractions. So if in a fraction I have negative 14 over 2, Remember, this is the same as negative 14 divided by positive 2, which is positive divided by, or negative divided by positive, it's a negative. 14 divided by 2 is 7. Okay? Or we have negative 14 divided by negative 2. That's equal to negative 14 divided by negative 2, which is going to be a positive 7. Again, because both values were negative, right? So if we have both negatives, the answer will be positive. Okay? So that's what I've noticed that a lot of students struggle with, or they forget. It's when they have fractions. You want to pay attention that you have either the same sign on the top and bottom, or that they have opposite signs. Because we're thinking, oh, well, if I write it as a division, then I'll get it. But then we tend to forget that a fraction is also a division. Okay. We can also have, using 14 and 2 and 7 again, we could have, negative 2 times negative 7, it's going to give us positive 14. Both have the same sign, even though they're both negative, it's the same sign. But if I have negative 2 times positive 7, then the answer will be negative 14. Okay, so we always want to make sure that we are paying attention with the signs that we have. These rules come from what I was telling you before with the negatives, right? If we have two negatives, they make a positive. Okay? So that's the rule. Now, there's something else that I want to mention in regards of multiplying and dividing with negative values, and that is exponents. So, exponents. I just realized that there was like a thicker, like pencil. Oh yeah, the other one is 0.35, this is 0.5. That's why these look like the same thing. Oh well. So there was like a marker type of thing, like it was gonna be like more thicker. I don't know. So exponents, right, with negative values. So we already went over exponents. We know that the definition of an exponent is, it tells us how many times we have to multiply the base by itself, right? But what happens if the base is a negative value? So let's say we have negative 2 to the second power. Well, then this will become negative 2 times negative 2, which will be negative times negative, positive. 2 times 2 is 4. So positive 4, right? Now, this is not the same as having negative 2 squared. With negative 2 squared, or negative 2 to the second exponent, would be negative times 2 times 2. This second exponent is only being applied to the 2, not the negative. If you have it in parentheses, then yes, negative is also going to be repeated, right? If you don't have parentheses, negative will not be repeated. It will just be like on the side. So this will become negative 4, okay? Let's say we have negative 2 to the third power. Then this will be negative 2 times negative 2 times negative 2, right? Now we know that negative 2 times negative 2 will give us, let me try to get that. Negative 2 times negative 2 will give us positive 4. But then we're still multiplying by negative 2. And positive 4 times negative 2 is going to give us negative 8. So that means that negative 2 to the third power is negative 8. So now we are getting a negative value. When we live in even, we got a positive. But now that it's an odd exponent, we're getting a negative. And that is the rule. That is the rule that I wanted to talk about today. So if for negative integers or negative bases, with even exponents, That means 2, 4, 6, 8, 10. So negative integers with even exponents give positive results. However, if the exponent is odd, then the answer or the result will be negative. Now again, this is only applying the um, if the integer, the base is negative. Okay, so this is like a golden rule for exponents. Okay. So one more time, if we have negative integers with even exponents, then the answer will be positive. But if we have odd exponents, then the result will be negative. Okay? So that is the rule. Okay, so that is basically all I'm going to cover for this first lecture. I'm going to be uploading also some assignments for for you to review this, and it's going to be part of your homework. It's going to be due on Sunday. So this is basically the first part of chapter 1. As you can see, it's all just basically basic math, just reviewing stuff that we have already learned before. And it's just preparing you for the next material that is about to come in the following weeks. I know it's going to get a little bit tedious, it's going to get a little bit annoying. The tutoring hours are going to be available. I'll try to see if I can go ahead and move my schedule around so I can be available for you guys in the morning. Right now, it's going to be the evenings. But again, if any of you need some extra tutoring time, don't hesitate to let me know so we can go ahead and schedule a tutoring session, right, whenever it's more convenient for you. So I'll be uploading these notes as well, just so you can have access to them. I know they're not super neat, not like the cleanest one, but if you want to go back, then you can have them, and them being accessible to you on campus. Okay.